22nd May GFG question, minimum deletions. So we are given a string and they're asking that what are the minimum number of characters that you can delete from this string in order to make it palindrome. Now what is a palindrome string? A palindrome string is a string that reads the same from starting to end and also the backwards, like A, B, C, B, A, right? If you read from this direction or this direction, the string remains the same. So for this, in order to make this palindrome, you can see that, okay, A is fine. There is no problem in here. Then you consider this E and D. Now here is its problem. So you can decide whether you want to delete E or delete D. Suppose you decided that, okay, I'm starting with deleting the first character. Okay, then you move B and D. You deleted E, that's why the pointer moves to B, and the backward pointer the right pointer is on D. So B and D, they are again not same. So you can either decide to delete B or D. Since we are choosing to decide the on the left side, so suppose you decided to delete B. Now of course it is, it is observable that you have to delete D because the B occurs here, but our code does not know that, okay, B might come next here. So it does not know the actual optimal character to delete. So suppose we're fixating that you have to delete first the characters of left side. So you deleted B. So now C and D are left. So again, they're not same. You deleted C. B and D are left, again not same. You deleted B, and D is, here. So that is fine. Yeah, ADA, that is the string that we get. So we have to delete four characters here. So suppose after you deleted E, you decided, okay, I'm not going to delete B, but I'm going to delete D. Then okay, you got a, palindrome string that is ABCBA. So you only deleted the characters E and D. So that is the most optimal solution for this example, that you have to delete two characters. Now, we observed that, okay, if we delete all the left characters and we do something like this, it is not working. So basically, whenever this kind of questions are given, there are generally only two solutions of these questions. One is greedy and another is backtracking, that you have to try all possible cases. And greedy is that you find the most optimal decision. Okay, that you are at position E and D, you encounter these two characters. You have to somehow develop your algorithm in such a way that you can accurately predict, okay, I'm going to delete E, and this is the most optimal case that I'm going to get. But here it is not the case. But still, if you don't understand and you are confused between the approaches greedy and backtracking, you can check the constraint always. So they are given as 10 raised to 3. In greedy, you generally have 10 raised to 5 or maybe even more, like 10 raised to 6 at max. But here the constraint are 10 raised to 3. So 10 raised to 3 is also a little trouble, because if it were given like 100 or maybe 500, then you can do backtracking. But 10 raised to 3, you might get a TLE on backtracking. You have to, optimize it a little using the dynamic programming. So whenever this kind of constraint are given, it is generally a DP question. So we are going to apply the DP here. We have two pointers, left pointer and a right pointer. We are going to check if the values, if the characters at both these pointers are same. If they're same, what you do, you don't have to delete anything, right? You just move your left pointer forward and you just move your right pointer -1 in order to make it D, right? So basically you move forward. And what else? Suppose we are at this E and D, right? Next. So we have to try all approaches, all cases. So here we delete E first. So that is, increment the left pointer and keep the right pointer as it is. And for D, for deleting D, you decrement the right pointer and keep the left pointer as it is. But in both the cases, you have to add 1 to your return value, because you are deleting one character and we have to find the minimum characters to be deleted. So that is the basic approach of memoization that we are going to use, right? So here is the recursion calls that I have written. So if you observe, we are going to start with 0 and 6. So this is 0, this is 6. We are starting with AA. Now we backtrack. There is only one backtrack from here. Why? Because we got AA, right? So we don't have to try all cases. There is only one recursion call, that is move forward. E and D, we do not increment in our return count also. So then we do backtrack for 1, 5. 0 incremented to 1, 6 decremented to 5. ED. Now these are different. So we have to try two cases. Case 1 is that, okay, we deleted character E. And case 2 is here that we deleted character D, right? So for BD also, we have again two cases, that you can delete B, you can delete D, right? But if you actually delete D, you get BB, that is same. So you move forward, then you get CC, and whenever your left pointer becomes greater than or equal to your right pointer, that means we have to return back, and we return 0 here. But if you deleted, C, then you might return 1 here. So we take the most optimal solution from this, that is the 0. So you basically get 0 from this call, right? of course, like ed, right? So you deleted e here, so our cost incremented to 1 here. And now in bd you deleted d, so you deleted b, I'm sorry. So here also the cost incremented by 1. So basically the most optimal here we got is cost 2 in this call, in this 1 5 recursion call. And for this 1 4 recursion call, again you can decide whether you have to. So here you deleted d instead of e, right? So here it is cost 1 and you go inside it. So in then you deleted e. So that is again the same approach. You can follow the recursion and you can just get the most optimal solution as 2, right? So let's check the code here. We are having 2 pointers left, right, and a string that is given in the question, and our vector of dp of 2d array. Why 2d array? Because there are 2 pointers that we are having left and right, and the size would be, the size of string, because the pointers can lie from 0 to n minus 1. You can also do this actually in off n space. I checked the article of GFG. I will provide the link in the description, but I don't fully understand dp that much in deep, so I don't want to do that, right? I wouldn't be able to explain it properly. Okay, so you can refer to it if you're smart enough to understand it. So this is a simple thing. If the left pointer is greater than equals to right, that means we have reached the end and there is no need to delete anything, so we return 0 here. If the dp, if the value is already calculated, we don't recalculate it. This is the only thing that leads to TLE, because backtracking does not have this line, so it keeps calculating the same sub problem again and again. If the pointers are same, we can just move forward by incrementing our left pointer and decrementing our right pointer. And otherwise what we do, we add 1 to our cost of deletion, and we provide the minimum of, you can delete the left character, so increment the left pointer, and you can delete the right character, so you decrement the right pointer. So let's just submit this, and it's working completely fine. You can also check the space optimization approach, that would be better. All right, otherwise this code you'll get in the description. Okay, thank you.